In this video, I will show you how to solve logarithmic equations. I need to start off by spreading this out a little bit. So I'm going to write log x. You know what? I didn't mean to use green. I'm going to write log x, which is log base 10. Just keep that in mind. Is equal to 3, and here's where I'm going to leave a little space, and then I'll have minus log 100x plus 900. So the reason why I left a little space here is because I need to turn this 3 into a log term so I can combine it with the other log term and sort of get it out of the way. Noticing that these other logs are base 10, I'm going to do the same thing here. So I will do log base 10, and when it's base 10, you don't write the 10. Excuse me. So I will just write log 10. In my mind, I'm thinking log base 10 of 10. But you don't write the 10. But if I did write the 10, it would make it very obvious to me that the value of this is 1. Because a log is the exponent that turns the base into the other number. What exponent turns 10 into 10? 1. So the value of this is 1. Now I'm going to go back and not write the 10. Alright, but still, the value of this is 1. So I have not changed anything. So the next thing I need to do is use the power rule, which tells me I can take this 3 and put it as the exponent. Okay, so I can make this 10 to the third power. Alright, now 10 to the third power is 1,000. So this is really going to end up being log of 1,000 on the next step. So that's what I have right now. I have log x equals log 1,000 minus log 100x plus 900. So now I can use the quotient rule, which says that if you have a log minus a log, you can condense this down to a single log using division. So this will be the same thing as log of 1,000 divided by 100x plus 900. Now that I have a log of something equals a log of something, the arguments must be equal. The part inside the log must equal the other part inside the log. In other words, x must equal 1,000 over 100x plus 900. So now it's just a matter of solving this. We could multiply both sides by the denominator. So I'm going to multiply both sides of the equation by 100x plus 900. So over here I'm going to have to do the distributive property. So that will give me 100x squared plus 900x. These will cancel each other out, so I just have equals 1,000. Now I'm noticing that all of these are divisible by 100. So I might as well make the numbers smaller by dividing everything by 100. Okay, so what I will get now is going to be x squared plus 9x is equal to 10. Subtracting 10 from both sides gives me x squared plus 9x minus 10 is equal to 0. Now hopefully this is going to be factorable, because that will make our lives easy. X squared can only factor as x times x. 10 will either be 2 times 5 or 1 times 10. Alright, considering that we want a positive 9, let's do 1 times 10. And let's do a negative 1 and a positive 10. Alright, that's how this factors down. So now we will set each factor equal to 0. So x minus 1 equals 0, and x plus 10 equals 0. So this will give us x equals 1, and this will give us x equals negative 10. Now, we have to be very careful of extraneous solutions. One or both of these might not actually work, and specifically keep in mind that you cannot take the log of a negative number. So I'm really worried about this negative 10. Let's look back at the original problem. Well, since there's a plain old log x right there, that tells me right away that x cannot be a negative number. So having this be a negative 10 is out of the question. That's undefined. Now, positive 10 would be fine. Positive 1 is the other solution. Positive 1 would be fine. No negative inside the log. Okay, so we will have to throw out the x equals negative 10. That is extraneous. And x equals 1 is our only solution. Let's look at another example. I will start off using the same strategy. I have log base 5 of x squared over 8 minus 3. Here's where I'm going to leave some space. And this is equal to log base 5 of x over 40. The reason why I left this space is because I need a log expression here to turn this into a log term. I'm noticing that these are both base 5. So I'm going to write log base 5, and then I'm going to say of 5. Because the value of this is 1, so I didn't really change anything. I will immediately use the power rule to move this exponent to the, to move this coefficient to the exponent. So this will be 5 to the third power instead of being a coefficient. Now 5 to the third power is 125. So what I have now is log base 5 of x squared over 8 minus the log base 5 of 125 is equal to the log base 5 of x over 40. Now I will use the quotient rule. This will condense down to a fraction. Division. So I'm going to have log base 5 of. So it's going to be x squared over 8 divided by 125. Now when you divide a fraction by something, all you do is put the thing you're dividing by in the denominator. So x squared over 8 divided by 125 is just x squared over 8 times 125. Just put the thing you're dividing by in the denominator. So this will equal log base 5 of x over 40. So now that I have log base 5 of something equals log base 5 of something, the stuff inside must equal each other. The argument must equal each other. Now, what is 8 times 125? I'm grabbing my 4-function calculator. So 8 times 125 is 1,000. So I'm just going to go ahead and write that as I bring it down. So I have x squared over 1,000 is equal to x over 40. So I am going to cross multiply. Now I could sit here and multiply both sides by 40 and then multiply both sides by 1,000. Or I can cross multiply, which is where you multiply these times each other and put that on one side of the equation, and then you multiply these times each other and put it on the other side of the equation. So if I do x squared times 40, then that is 40x squared. And then if I do x times 1,000, put that on the other side, so that is going to be 1,000x. Now, you're going to be tempted to divide both sides by x. Don't do it, because x might be 0, and you have to be careful not to divide by 0. So instead, what you should do is subtract 1,000x from both sides. So I'm going to subtract 1,000x, and so that will give me 40x squared minus 1,000x is equal to 0. There's definitely a common factor here. Let's see how many times 40 goes into 1,000. Well, that's 25 times. So the greatest common factor is 40x. So that's going to leave behind x minus 25. Okay, if I set each of these equal to 0, then I will have 40x equals 0, and I will have x minus 25 equals 0. Dividing by 40 gives me x equals 0. Adding 25 gives me x equals 25. Now, the x equals 0 is going to turn out to be extraneous. You can't take the log of 0. And if I were to plug 0 back in, for example, right here, 0 divided by 40 is 0. Then I've got the log of 0. There's no power that will turn 5 into 0. So x equals 0 is extraneous, which means x equals 25 is my only valid solution. Okay, I'm just quickly checking to make sure 25 doesn't cause any negative numbers, and it does not. So x equals 25. That's the answer to problem number 5. Let's do one more problem for this video. Now this one will save us a step or two because there is no constant floating around that I need to turn into a logarithm. So I can skip straight to the part where I combine these two logs into one. So this will be the same thing as the natural log of x times x plus 2. Because when you have the sum of two logs, it condenses to multiplication. So x times x plus 2. So of course that means I have natural log of x squared plus 2x. Alright, I'm just doing the distributive property right here. And that equals the natural log of 63. So now the argument must equal the other argument. So that means x squared plus 2x must equal 63. Subtracting 63 from both sides, I have x squared plus 2x minus 63 is equal to 0. With any luck, this is going to be factorable. Okay, so this is going to be x squared can only factor as x times x. 63 is going to be 7 times 9. I need it to end up with a positive 2 in the middle, so that's going to be a negative 7 and a positive 9. Setting each of these equal to 0, alright, I've got x minus 7 equals 0, and then x plus 9 equals 0. Alright, I'm going to get x equals 7, and then I will get x equals negative 9. Now I need to check and make sure that none of these are extraneous, and you cannot take the log of a negative number or 0. So I quickly see that x equals negative 9 is extraneous because right here I've got just plain old natural log of x. If I let x equal negative 9, then I'm taking the log of a negative number, and that's undefined. So that makes this extraneous, which means that x equals 7 is the only solution to problem number 6. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.